All right, so we're looking at a homework assignment here. Venn diagrams homework. In a company, and it's been a while since I'm rusty on Venn diagrams. I haven't taught them since probably 17 or 18. It's probably been 6 years since I've done an actual Venn diagram lesson. But in a company, there are 110 workers. So my little rectangle has a population of 110. I'll kind of write that off to the side somewhere. There's 110 people in here. 90 workers like tea, so I'm going to have a circle about tea. And 41 workers like coffee, so I'm going to make another circle about coffee. And 25 workers like both tea and coffee. So the shared space, and that's what this is, that's that overlap, is 25. Now, I need to work with some numbers here. There's a total of 41 workers who like coffee. And I've already aware of 25 of them, so 41 minus 25 is 16. The rest of that circle has 16. 90 workers like tea, but I already know about 25 of them, so 90 minus 25 is going to be 65. The rest of that circle has 65 people in it. Now, if I put these numbers together, I get 106. 106 like coffee or tea. So that means there's 4 people who don't. All right? This is the people who don't like coffee. So how many workers like neither tea or coffee? 4. All solvable with a Venn diagram. Don't do these things in your head. Just draw the stupid picture. Here is a Venn diagram. Now, I need to remember to do this for sure. This is also read, we read this a couple of ways. We read this as the probability of A and B. It's also read as the probability of the intersection of A and. This is actually B prime here, the complement, or not B. Hopefully I remember that. So here's what I'm going to do. I'm going to write down what's in A. So the set that contains A is a 4, a 5, and a 1. Let me put that in some curly braces like it's supposed to be. A 4, a 5, and a 1. Now B prime is read not B. All right? So not B contains the elements 4 and 12. Now, the intersection of A and not B is just going to be 4. It's the thing they have in common. I guess I should say that too. Intersection is what they have in common. So here's what we have. The union of these two things, if we talk about A, not unioned, A and not B prime, is simply a set that contains a 4. Now, if you count these things, there's 1, 2, 3, 4, 5, 6, 7 things. There's 7 outcomes. This union is only one of 7 things. So if I'm going to address answer A, it's 1 and 7. There's a lot of little stuff in there. A lot of little stuff. I'm going to try and run through the rest of this pretty quick because that was the bell, and that means I have to go to tutoring. Write down the probability of not A and not B. Okay, and that's or. This is not A or not B. So not A is going to be an 8, an 11, and a 10, and a 12. 8, 11, a 10, and a 12. And not B, because of the prime notation, not B is going to be a 4 and a 12. Now this is an or statement. An or statement is everything that's in both. Let's try and do this in order here. All right, so I'm going to try and go in increasing order here. There's a 4, there's an 8, there's a 10, there's an 11, and there's a 12. You don't need to write the same thing twice. Now the probability of this happening, this was 5 events out of 7. So the probability of A prime or B prime is simply 5 and 7. C is kind of different. C is read the probability of event B happening given A has occurred. So event A has 3 things in it. What we're doing is we're only picking from event A. Just this. There's 2 things that can also be B. So the probability of B, given we're only focusing on event A, is simply going to be 2 and 3. And there you go. And that's where I got to stop because I'm already late for tutoring. So anyways, there's 2 of those questions. Not a whole lot to go, really. It's kind of a short section.